Find the domain of h of x plus 7, x over x squared minus 49. The denominator of f of x is x squared minus 49, and this should not be equal to 0. That means x squared should not be equal to 49. That means x should not be equal to plus or minus 7. And this can be expressed as two ways. X such that x is not equal to negative 7, or x is not equal to positive 7. In interval notation, I would write it as negative infinity to negative 7, or negative 7 to 7. I don't have space, I'm just going to squeeze it in here, or 7 to infinity. Find the domain of f of x, where x plus 7 over x squared plus 49. When I look at this, when I look at x squared plus 49, this is never going to be a 0 because the square is always going to be positive. 49 is always going to be positive. So there is no real number that can cause the denominator 0. That's why the domain of this would be all real numbers, would be negative infinity to positive infinity. True or false? If f of x goes to 0 as x goes to infinity, then the graph of f approaches the x-axis to the right. This is a true statement, because if I could draw an example of it, I'm just going to draw, so f of x is going to 0. I'm just going to draw something. F of x is going to 0 as x is going to infinity. That means the graph f approaches x-axis to the right. So that is a way of looking at it. Find the vertical asymptotes, if any, of the graph of the rational function h of x. The numerator and denominator have a factors in common. So let's go ahead and simplify that. If I simplify, h of x is equal to x over x times x plus 4. When I go ahead and simplify that, I will simply end with 1 over x plus 4. The only 0 of the denominator of the simplified function is negative 4. That means x plus 4 should not be equal to 0, so x should not be equal to negative 4. Thus, the line x is equal to negative 4 is a vertical asymptote for the graph. That's the line x is equal to negative 4. So here the vertical asymptote would simply be x is equal to negative 4. And remember, how do we find the vertical asymptotes? We always simplify the function first, and we're going to set the denominator equal to 0 to find the vertical asymptote. That's the first thing. So in the first step here, I simplified the function, and in the second step, I set the denominator equal to 0, and the third step would give me the vertical asymptote. So this is a vertical asymptote. Find the vertical asymptote, if any, of the graph of the rational function. So to find the vertical asymptote, the first step is to go ahead and look at the denominator. The denominator in this case is x squared plus 4, and the second step is to set it equal to 0. So x squared plus 4 equal to 0. When I go ahead and solve for it, I will see that the denominator cannot be factored and the denominator does not have any real zeros. Thus, this does not have any vertical asymptotes. So no vertical asymptotes. Problem 4. Find the horizontal asymptote, if any, of the graph of the rational function. Remember, to find the horizontal asymptote, the first thing you're going to see is look at the degree of the numerator. In this case, the highest power here is 2x of the numerator, and the denominator is 3x. So that means the power is 1 for the numerator, the power is 1 for the denominator. So step 2 is to go ahead and see what we should do. When the power of the numerator is equal to the denominator, the horizontal asymptote y is simply the coefficient of the numerator, which is negative 2 over 3. Find the horizontal asymptotes, if any, of the graph of the rational function. And again, the step to finding the horizontal asymptote is looking at the degrees. So the degree of the numerator is 12x, which is 1. The degree of the denominator is 2. So the degree of the numerator is less than the denominator. So the horizontal asymptote is y is equal to 0. Use the graph of f of x is equal to 1 over x to graph g of x, which is 1 over x plus 1 minus 2. We're going to start with the graph of f of x and 2 points on it. So I'm going to start with the graph f of x is equal to 1 over x, and 2 points I'm going to take on the graph are -1 and -1 and +1 and +1. So first I'm going to move the graph 1 unit to the left, which gives me 1 over x plus 1. So when I move the graph 1 unit to the left, it gives me 1 over x plus 1. So what happens now is the points 1, 1 become -2 and -1. The point 1 and 1 become 0 and 1. So in this case, my vertical asymptote would be x is equal to -1. Next, what I'm gonna do is I'm gonna move this graph 2 units down. When I move this 2 units down, the points -2, -1, this point -2, -1 would now become -2, -3, and the point 0, 1 would become 0, -1. And my horizontal asymptote in this case would be y is equal to -2. So when I go ahead and graph that, my vertical asymptote is -1, which is here. My horizontal asymptote is -2, which is here. And my graph would be something like this. Be something like this. And this point here would be -2, -3, and this point here would be 0 and -1. Graph f of x is equal to -1 over x squared minus 4. So my step 1 here is to look for the symmetry. So f of -x, and that would be -1 over -x squared minus 4, which is -1 over x squared minus 4. So f of -x is equal to f of x. That implies that it's an even function. Step 2, that means it is symmetry along y-axis. Step 2 is to find my y-intercept. So how do I find my y-intercept? I simply set my x is equal to 0. So f of 0 is -1 over 0 squared minus 4, which is -1 over -4, which is 1 over 4. My step 3 is to find my x-intercept. How do I find x-intercept? I set y is equal to 0. So 0 is equal to -1 over x squared minus 4. So when I cross multiply, I have 0 is equal to -1. That tells me that I have no x-intercept. Step 4 is to set the denominator equal to 0. So when I set it equal to 0, step 4 is to find the vertical asymptote. And how do I find the vertical asymptote? I set denominator equal to 0. So x squared minus 4 equal to 0. X squared is equal to 4. That implies x is equal to positive 2 and x is equal to negative 2. That means I'm going to have two vertical asymptotes in this case. Step 5 is to find the horizontal asymptote. Looking at the power of the numerator and power of the denominator. Power of the numerator is 0 and the power of the denominator is 2. So if the power of the numerator is less than denominator, then my horizontal asymptote is y is equal to 0. Step 6 is to plot some points between and beyond my x-intercepts and my vertical asymptotes. So here I'm going to take my x values and f of x values. So for me to get the values, I don't have my x-intercept, so I'm going to take values between and beyond the vertical asymptotes. So my vertical asymptotes here are negative 2 and positive 2. So negative 2, I'm going to take a value negative 3. I'm going to take a value negative, negative 1. I'm going to take a value 1. And I'm going to take a value 3. Remember, I cannot plug in 2 because it's a vertical asymptote, so there is no value here. But I'm going to go ahead and look for the other values. So when x is negative 3, my value is, I'm going to plug in negative 3 in the function, which is going to give me negative 0.2. When x is negative 1, I'm going to have a huge value here, but I'm simply looking at if the value is positive or negative. So when I'm going to plug in negative 1 here, I get negative 1 squared is 1, 1 minus 4 is negative 3, so it's going to be negative 1 over 3. So when x is negative 1, I would get the value. You're going to plug negative 1 in the value. You're going to get 0.333. And when x is positive 1, you're going to get 0.333. When x is 3, you're going to get negative 0.2. So which is these values just give us the idea of how the graph would be. Would it be above or below x-axis? So I'm just going to go ahead and draw this now. This is my first vertical asymptote, which is negative 2. This is my another vertical asymptote, which is positive 2. And remember, the y is equal to 0 was my horizontal asymptote. And taking the values for negative 3, it is going to be negative, right? So somewhere here for positive 3, the value is also negative. For negative 1, the value is 0.33. For positive 1, the value is 0.33. So when I go ahead and graph it, I know my graph would be something like this. Getting closer to the horizontal asymptote. Getting closer to the horizontal asymptote as x and y. Remember, I have a y-intercept at negative 0.5, so this is how my graph would be. And when you look at it, as x goes to negative infinity, the values get closer and closer to y is equal to 0. As x goes to positive infinity, the values get closer and closer to 0. And this is my vertical asymptote. It's going all the way up here and getting closer to negative 2. There's another vertical asymptote here, goes all the way up and gets closer to positive 2. Find the slant asymptote. Note that the graph here has a slant asymptote because the degree of the numerator is exactly 1 more than the degree of the denominator. So what do? How do I find my slant asymptote? I'm going to go ahead and use synthetic division. When I use synthetic division, I'm going to use the coefficients of the numerator. 1, 1, negative 6. And I'm going to use the denominator, x minus 3, so here it would be positive 3. Bring the first one down. 1 times 3, 3, 1 plus 3, 4, 4 times 3, 12, and positive 6. And the slant asymptote would simply be this part. That would be simply x plus 4. So y is equal to x plus 4 is my slant asymptote. The average cost is divided by the number of bikes produced. So in this case, I would have C of x is equal to 100,000 plus 100x over x. Find and interpret C of 1,000 and C of 4,000. So here C of 1,000 would simply be, let me see the function here, it would be 10000 plus 100 times 1,000 over 1,000. So the average cost of producing 1,000 bikes would be simply $200. And C of 4,000 would be simply 100,000 plus 100 into 4,000 over 4,000. And that would be the average cost of producing 4,000 bikes would be $125. You see, as the more bikes I produce, the average cost comes down. Now, what is the horizontal asymptote for the graph here? And describe what this means. So that when they ask you what is the horizontal asymptote here, they're trying to ask you, like the cost of the bikes approaches what value as the bike value increases. So let me go ahead and do the horizontal asymptote here first. The horizontal asymptote in this case would, remember, simply the power. Let me go ahead and write the function first. The function C of x would be 100,000 plus 100x over x. How do I find the horizontal asymptote? The power of the numerator, which is 1, or the power of the denominator, which is 1. The powers of the numerators and the denominators are same, so my horizontal asymptote would simply be the coefficient of the numerator over the coefficient of the denominator, which is 1. So y is equal to 100 is my horizontal asymptote. So what exactly does this mean? This means that as the x values are increasing, that means as I produce more and more bikes, so when the x value increases to infinity, the y value goes closer and closer to 100. That means as the more bikes I produce, the cost of producing the bikes would get closer and closer to 100. So graph f of negative x over x plus 1. The certain things in graphing a rational function, the first thing would be looking at the symmetry. So to look at the symmetry, I'm going to find f of negative x. So negative of negative x over negative x plus 1, which gives me positive x over x plus 1. This tells me that as f of negative x is not equal to f of x, nor negative of f of x, this function is neither symmetry along y-axis nor origin. My step 2 is to find the y-intercept. How do I find the y-intercept? You set x equal to 0. So it's negative 0 over 0 plus 1, which is 0 over 1, which is 0. So your y-intercept is 0. The next step is to find your x-intercept. How do I find x-intercept? I set y equal to 0, so negative x over x plus 1. When I cross multiply, I get 0 is equal to x. So my x-intercept is 0 as well. My step 4 is to find vertical asymptote. How do I find vertical asymptote? I'm going to simplify the function first. That's my first step. In this case, I cannot simplify the function. So So I'm going to set the denominator of this function equal to 0. So that is simply going to be x plus 1 equal to 0. So my x is equal to -1. 5 is to find the horizontal asymptote. How do I find the horizontal asymptote? I will simply look at the power of the numerator and the power of the degree of the numerator and the degree of the denominator. The degree in this case is 1. The degree in the denominator is 1. When the degrees are equal, my horizontal asymptote y is simply the coefficient of the numerator over the coefficient of the denominator, which is -1. My step 6 is to take points between and beyond the x-intercept and the vertical asymptotes. First, I'm going to write my vertical asymptote, which is -1, and my x-intercept is 0. And now I want to take values between and beyond. So -2. -0.5, 1, and I'm gonna say 2. Remember, I will not have a value for x is equal to -1 because that is my vertical asymptote. Now I am going to go ahead and find the rest of the values. When x is -2, let me go ahead and clear this one. Just give me 1 second. When x is -2, my value is negative. My y value is -2. When x is -0.5, my y value is 1. When x is 0, my y value is 0. When x is 1, my y value is -0.5. When x is 2, my y value is -0.667. So now I'm going to go ahead and use this information to graph my rational function. So this is my vertical asymptote. X is equal to y is equal to -1 is my horizontal asymptote. This is my intercept, and this is -0.5. This is +0.5. This is +1 and 2. This is -1, and this is -2. Did I put it too close? Yeah, too close. Alright, now I'm going to go ahead and see what the values are. When x is -2, y is -2, so somewhere here. When x is -0.5, the y value is 1, so somewhere here. When x is 0.5, when x is 1, the y value is 0.5, so above -1. And when x is 2, it's -1.66. So using this, I know that my graph would be something like this, crossing the origin. And that's what the graph is going to be. So these points between and beyond help us to analyze where the asymptotes and the graph should be below